Oh, I just let somebody in and I think I forgot who I let in. So let me look. Oh, Rosie. So Ada, how many hours how many hours a week do you work?
It used to be 28, but I dropped it down to 18. So
Wow,
hopefully that'll help.
that's a lot.
Yeah.
So we can get a couple more people in here before we start. Oh, I guess, oh, wait, we do start soon. All right, I'm gonna rearrange my screen. Okay, so I need you to get your notebooks out. So we're gonna take some notes in class and then we're gonna do things a little bit differently. Hold on, let me let Ryan in and Sadie in. So we're gonna do things a little bit differently in that we're gonna do a little bit of notes and then I found a Desmos activity that I think does a really good job, maybe even better, or maybe just differently than what maybe just different from what I see in Delta Math. So it's not better, it's not necessarily worse, it's just different. It's a little bit more interactive, and I'm gonna have you do it in groups. But the first thing I want to do is make sure you're all on the same page. And I want to talk about, let's see here. All right. Can you guys see my screen? Perfect. So we got to kind of talk, and some of you have already probably have these notes. So you may not even need to write these notes down because this part, at least this first part, the stuff that you see here is all stuff you probably already have down if you're caught up to date on the assignment, on all the assignments. You probably already have these already down. But when we talk about, you'll hear this word critical number a lot. And what that just refers to is it simply is when the first derivative is equal to 0 or is undefined. That's all a critical number is when a derivative is equal to 0 or undefined. Most of the time when you get an equation, probably 99% of the times if you have an equation, it's going to, the derivative will equal 0. There are times when you'll get a graph or something else when the derivative is undefined, but very rarely do you have undefined derivatives. I mean, the absolute value is maybe one of those. Anytime you get a sharp change in a graph, that's when you're going to get an undefined derivative. But most of the time, if you're just given an equation, you can figure out critical numbers by taking the derivative and then setting it equal to 0. Then there's this idea behind a relative maximum, and relative and local are synonymous. So if you see the word local maximum, that's the same thing. And that's a peak or a hump in the graph. So it's some kind of a peak in the graph or some kind of hill in the graph. Where a relative minimum is a valley or a dip in the graph. So that's where the graph has some kind of a dip. And so think about the relation of what those are as far as what a relative minimum and a relative maximum are. They're not really, they're really describing like the characteristic of the graph more than anything. So that's what a relative minimum or maximum is. Any questions on that before I move on? All right, so several years ago, I made a thing called the chart. And it looks like this. And I thought it was a pretty unique name that I called it the chart. I mean, there's a lot of creativity in there because it's a chart. And it's just a way that I found that when I was teaching it, I was organizing my thoughts this way. And then I started just teaching it this way. And so this chart is just pretty much simply a matrix now across the top. So I want you to copy this down because you'll copy this down several times this year. If you take the AP exam live, my guess is some of you will write this down right out of the gate when you get to the AP exam. The idea behind this is you got the first column is F, the second column is F prime, and the third column is F double prime. Now, they're kind of generic in the sense that I could make them G, G prime, G double prime, so the letter doesn't matter, the derivative part matters on where they are. And then those side arrows, we'll talk about what those are as well. And you've actually written down part of this already. So some of you might go, didn't we write this down already? And the answer is yes. And the answer is you'll probably write it down several more times until you have it ingrained, because it's a way of organizing your thoughts and your justifications for a lot of these problems. So have you had enough time to copy at least this down? Let me start filling it in. Anybody need more time to do that? All right. So in this chart, in this first part, I'm going to write the word increasing right here. So that's the idea where a graph is going up. So if F is increasing, so as you read it from the left to the right, it's going up. When you think about drawing tangent lines, any tangent line, which the derivative is the slope of the tangent line, is going to have a positive slope. So anytime a function is increasing, its derivative has to be positive. Positive meaning above the x-axis, whereas negative would be below the x-axis. You could write decreasing here. And intuitively, hopefully, you write negative. So the idea behind that is if a graph is going down, if F is going down from the left to the right, all of the tangent lines, so all of the slopes of the tangent lines, which would be the derivative, would have negative slopes. So if you graphed them, they would be, if you graph the values of those slopes, they would be below the x-axis. We actually don't get anything, there's no new information that comes from there. So you can kind of cross those out. But because the next lines down, we have to talk about the second derivative. I just left them in there. Okay, so you don't really get anything new. Now, on these arrows, if you think about a graph going from increasing and then to decreasing. So if you think about a function f going from an increasing function to a decreasing function, hopefully you kind of picture in your head a peak. And so that's where you get a relative maximum. On the function f. So it's not a relative maximum on f prime, it's a relative maximum on f, because you think about f is going from increasing to decreasing. What f prime is doing is it's crossing the x-axis in that case. F prime would be going from positive values to negative values. Now on the other side, going from the second line to the first line, that is a relative minimum on f, because that's the case where you're going from a decreasing function to an increasing function. So f is going to have a dip or a valley in the graph, and f prime would be crossing the x-axis, but it would be crossing the x-axis from negative values to positive values. Any questions on that?
Yeah, me.
Yeah.
Okay. So in your video, you talked about relative extrema.
Yep.
And you said it was like it was just the maximum, right?
Well, it's a peak or a valley. So relative, so extrema means like minimum or maximum. So extrema would mean a relative minimum or a relative maximum are relative extrema. Does that make sense?
Yeah, I just got confused because I think in your video you forgot to say the minimum part, because then in like the problem you did, you included the minimum, but I guess it means both, so.
Yeah.
Yeah.
Relative extrema, that can be minimum or maximum. That's pretty much like more generic, not defining one or the other. So then we have this next layer down. And with this next layer down, we're going to write increasing here. And we're going to write positive here. Because the second derivative is the derivative of the first derivative, it should have the same relationship as f and f prime. F prime and f double prime should have the same kind of relationship when you think about it. Does that make sense? And so you can bet that I'm going to write decreasing here. And I'm going to write negative here. Okay. Now, as far as these relative maximums or relative minimums, this is a relative maximum of f prime. Because in that case, f prime is going from increasing values to decreasing values. And over here, this is a relative minimum of f prime, not f, but f prime. Don't cross these out. This box and this box, we will fill in, but we'll fill it in after when we get to the next section. We'll fill it in. It does give us information on f, but it doesn't, but I'm not going to get to that. You won't need that today. So the other ones, the ones on the first two lines, cross out that f double prime, but not on the first one. Just leave them blank for right now. Okay. Any questions on that? Okay. So here's your job. Here's what you're going to do. So I'm going to put you. So let me get 1 second. Let me find the things. I have so many windows open. Okay, so in Schoology, I could drop it. Maybe I could drop it in the chat too. In Schoology, if you go to today's folder, Jonah already tried to do this and I had paused the activity so he couldn't get very far, but thanks for working ahead, Jonah.
No problem.
Yeah. If you go to week 17 and you guys go to Monday, you don't have to do it quite yet. There's a Desmos activity, but when I click on it, I want to show you something. When I click on it right here, it kind of pulls up this fictitious sign in with Google. It even highlights it. That's not where you sign in. You actually have to, this up here, that blue part up there is the sign in link. And so here's what I'm going to do. There are 19 people in this room, in our Zoom. So what I'm going to do is I'm going to put you in breakout rooms. I'm going to put you in 5 different breakout rooms, and I'm going to unpause the activity. And the activity looks like this right here. And I could maybe get, let me see if I get a student link. If I get this student link and I throw it into the chat, that would be, you could access it that way. Sign in with your school. It's in the chat now. Sign in with your school. I'll throw it in there again just because Rosie just joined. Again, something must happen. So it's in the chat. You can sign in that way. or you can sign in using Schoology. But I'm going to put you in breakout rooms. And what I'm going to do with those breakout rooms is I'm going to have you work together with 2 or 3 other people, because there's going to be one group of, well, actually everybody's going to have 4 people in a group, because there's 20 of you in here. And I'm going to unpause the activity and I'm going to let you work through it. And if you have a question, what I want you to do is just, there's a way to raise your hand in the breakout rooms and have me come in there, and I'll go in there with you. And I'm going to randomly assign the breakout rooms. So I'm not going to assign them. I'm going to create, let's see, I want to create 5 breakout rooms, and I'm going to assign them automatically. So when I create them, there's 4 people per room, and then you guys can work on them together. So some of you are not in yet. I can see who's in and who's not in. So those of you who are not in yet, is there something I can help you with? If there is, you got to let me know. The easiest way to sign in is using your Google account from SLP. Okay, so I'm going to get you started on this, because we got a half hour, and you can get relatively far away. And if you get stuck on the directions, let me know, and I'll come in and explain it to you. But most of it is matching up the derivative graph with the function graph. So matching a function and its derivative together, and really kind of hone in on the chart. If you hone in on the chart, specifically, I think this first 2 lines, because the second 2 lines are the same thing, right? I mean, they're pretty much the same thing. I think you'll be in a place where you can make some sense, and you'll have somebody to work with on this. So this is what we're doing today. So I'm going to throw you in there. Ready? Any questions? Okay.
Mr. Alquist, can you move the diagram back on the screen? I was like, my Wi-Fi wasn't working, so I couldn't like write it down.
There. Why don't you take just so you can get into the room, why don't you take a picture of it with your phone or something, and then you can, and I'm recording this so I can show it to you later, unless you only have a couple more things to write in there.
No, I just took a picture.
Okay.
I'll write that down later. Thank you.
Yep. Ryan and John, have you accepted your?
I was also taking a picture.
Oh, thanks. Sorry.
That goes with the parabola that
No.
has max at -3, +5.
The one with a slope of 3 that goes through 0 goes with the straight line.
Straight line at 3. Yeah,
Yeah.
okay, that makes sense.
Because the ones that go through the origin are just straight. Because the derivative of those is a constant.
Wait, then which? Oh my god.
Mr. August, can we like have the ability to share our screens?
Yes, I was just right when you asked that. I was
Can you also explain what you said in that message again? Because it went away.
okay. You should be able to do it. Which message? The first one or the second one?
The second one where you were like, think.
Okay, so when you think about like when you're going through them, if you see a peak in the graph, like a hill in the graph,
Mhm.
then its match has to be going through the x-axis at that same x value from the positive side to the negative side.
Positive to negative.
Because it's going through a peak, right? The slopes are going from positive values to negative values at that x value. So the match of that has to be going through the x-axis from positive above the x-axis to negative below the x-axis.
Okay, can you give us an example of one of these?
So looking at yours right now. So pick any one of the parabolas.
Okay, the one at 5, where the lowest is at 5.
The
This one.
lowest is at 5.
The
Oh.
minimum is at 5.
Okay, so then you need a graph that goes from negative values, because that's a relative minimum, right?
Oh, that goes from decreasing to increasing?
Well, that graph goes from decreasing to increasing, right? That
Oh,
graph that looks like a parabola goes from decreasing to increasing.
yeah.
So its match has to go from negative to positive at that same x value.
Negative to positive. Oh, so it would be the one where it. Oh, okay.
Pull it
So
together.
yeah, okay, I know which one.
That makes much more sense.
I
Yeah.
understand.
Okay?
At the x value, you said
Yep.
3. Okay, so the one at -3 is going from increasing to decreasing. So then it has to go from positive to negative
Right.
at -3.
Exactly.
Oh, this makes so much more sense.
That was very helpful.
That's really
That's
cool.
what Ada was trying to tell you.
Sorry.
No, you're good. Hopefully this is helpful because you got about 15 minutes left. So keep going. I'll pull you back with like 5 minutes left in class and we'll kind of sum it up. Okay.
Right.
You'll have time to do this after class. You'll have time to finish it. But I wanted you guys to be working together anyway.
Okay.
Okay. So do you need me anymore?
Mm-mm. I don't know.
Okay.
All right, I got all
What are we supposed to do when we finish?
You should make sure the people in your room don't have questions.
Okay.
So can you join again, or can I move you there?
Yeah, I can join again.
Because I think it would be helpful if, to answer your chat, yes, you were right. The concavity thing, what you said, concave up goes with that one, and concave down goes with the next one, and that's the next thing we're getting to.
Okay.
So see if you can help, because I think Madigan maybe needs some help, and well, I think some of those guys might need some help. So see if you can give them some guidance on how you thought about it.
Yep. Okay.
Okay, thanks. All right, what do you guys have questions about? You're all muted.
Hi, Mr. Alquist.
Hi, I'm here to help you because I feel like some of you are having some trouble with this first one.
I have tutoring today, and besides that, anything? Yes, and I don't know what I'm saying.
So what are you guys having questions? Are you even working on it? I think Bennett's tried it a couple times.
I'm just confused on how to find the derivative off of the other graph.
Okay, so here's what I want you to do, Johnny. I'm gonna pull up yours, and I'm gonna
Okay.
share my screen with you guys. And here's what I want you to think about. On this, so you guys should be able to see my screen. Hopefully, I don't even know if the other three are on here, but I'm gonna guess that they are. So what you should think about is, if I take a graph like this one right here, this one that I'm moving, that I just moved, okay? So this graph goes from increasing to decreasing right here at 2. Does that make sense?
A little bit.
I mean, it's an increase. It's a graph that's going up, and then it gets to 2, and then it goes down.
Yes, I got that.
Okay. So if this is a graph that's going from increasing to decreasing at 2, we need a derivative. We need a matching graph that's going from positive values to negative values at 2. Well, if you look at it, like this one's going from positive to negative values, but at -3.
Yes.
Look at this one right here. It's going from positive values to negative values at 2.
Okay.
So those should go together. See how they match up? See how this one crosses the x-axis when this one reaches a peak?
Okay. Oh. So basically what you're saying is you want to find the x value and the same x value for another graph?
Yeah, and you want them to
Basically.
be doing the same thing. Like if you look at this one right here, I just moved up here for you. So this one's going from decreasing to increasing at 5.
Gotcha.
So we need a graph that goes from negative values. We need a derivative graph that goes from negative values to positive values at 5. That's this one.
Goes from negative to positive. Is that because it's decreasing and increasing, right?
Exactly. So decreasing to increasing matches up with negative to positive.
Okay, so then I'm gonna try the next one. We have the x value, which is decreasing from -5, which could correspond with the increase and the decrease at -5 too. Or I feel like that was a very bad. Yeah, that one you're hovered over and the one next to it. Right?
So this
No. The one right below that.
one?
To the right. Yeah, that one and the one to the right.
So this one and this one here,
Yes. Would those two go together?
I would agree.
Ah.
Because it's going from increasing to decreasing.
Okay,
And
gotcha.
this one's going from positive to negative.
Right. Okay.
Okay, I got to join a different breakout room. Okay.
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 It's at x equals 3, and then you have to find the other one that goes at x equals 3.
Yeah, so like for the one that goes through
Like
x
these
equals
would go.
-3,
Oh, sorry.
for the one that like goes through x equals -3 and x equals -6, the parabola, that
X
one goes.
Where is that one?
I think you just
Oh yeah, wait.
Yeah.
1, 2, 3.
Oh, here.
that one, yeah. That one goes with the one that changes direction at -6 and also changes direction at -3.
Right here.
Wait, how?
That one changes direction at -4.
Oh, this is the wrong one.
Yeah.
Sorry, guys. I'm trying
good.
to see all the right numbers.
Oh my god.
Wait, which what's it called are you talking about?
I'm gonna because it's 211 or 311. I am going to end the breakout rooms and bring you guys back together. Okay.
Oh, I should probably stop sharing my screen. How do I do that?
Bye. I think there's like a green thing at the top.
Oh yeah, there we go.
All right. So the idea behind this, and it looks like some people maybe have left or they haven't left their breakout room yet. I can't remember. Oh, here they come back. So first off, you can just put you can do it, put something in the chat to everybody, or you can just put something in the chat to me. I'm curious to know whether you found this worthwhile or not. That's the first thing. The second thing is, I think that this is the first time I've had an opportunity to give you something where you really can work together on matching those things. Every one of this is your homework for tonight, and it's available you are welcome to continue to work on it. But you should make sure that you check it on that next slide. So if it says you got something wrong, you should go back and look at it. But the key is, what you want to look at is you want to look at those peaks and valleys on the graph. So if a graph has a peak at a certain X value, then its matching one has to go through the X axis from positive to negative at that same X value. So this is the first time that this is the first time that you've had to do this, and you'll have to do it a lot. So if this was hard, that's okay, but we'll keep on doing it. We will just keep on doing it because it's something you have to know how to do. This chart is one of the most important things. Okay. So hopefully it was helpful. I think that working in a group was certainly not isolating, and I'm trying to respond to that feeling. And but you got to work together, and I will continue to just randomly assign groups. And even if you stayed on and worked on the assignments on the asynchronous days, I would be happy to assign you to a group or to sit there with you while you do the problems. Okay? So you don't have to feel quite so alone. And I think it's really good to talk about it with other people. But if you don't get them all right on that second slide when you check it, or the sixth slide when you check it, you should go back and see what you got wrong. Okay? Well, you're welcome to leave. If you want to stay on and ask me another question, I'd be happy to sit here for a few more minutes and help you.
That is me.
Bye, Alquist.
Bye.
All right. I have another question.
Okay.
It says I got them all wrong. For if it doesn't intersect 0, like on the X or Y or whatever, but you know that one. Shoot, how do I describe it?
Okay. So let me, you actually did pretty well. Hold on. I'm going to share my screen, Johnny, because there's
Sounds
only, it doesn't say you got them all wrong, I don't think.
It did say I got them wrong. Not all, but I got
Right.
some.
Okay. So you should see my screen.
Yes, I do see your screen.
Okay. So I think these are right here.
Okay.
I just collapsed them just using this thing. I think these are right. I think these are right. I think these are right. So here's what we got. Now, take a look at these 3 things, okay?
Okay.
And I want to look at this one right here. What kind of slope is that? Positive or
yeah.
negative?
Oh, negative.
Okay. So if that slope is negative, its derivative always needs to be negative.
It would have to be. So it won't be a positive. Gotcha.
So which one is it?
The one right below it.
That's right. These go together.
Oh, that actually makes sense.
Those go together. Now you should be able to put those together and check it. And there you go.
Yeah, I got them right.
Yeah.
Oh, that's so helpful, actually.
So that was really good. So your key is work with your tutor tonight, Johnny, on the next of these slides. Okay.
All right.
And it's a super huge thing to know how to do to match these up, because then you start to see where the derivatives make sense together.
Okay.
Okay.
Great.
All right.
All right. Sounds good. Thank you, Mr. Walquist.
Yep.
You have a
Davis,
good
how
day.
can I help you?
I just want to know if on the 5th slide,
Yep.
I got all of those right.
Okay. So this is your 5th slide right here, right?
Yeah.
So if you go to the next button,
Yeah, no, that's the thing. It's saying I got them all right, but I did all of this first try, and that just doesn't seem right to me.
let's see. So let me look at, it's saying you got them all right.
Yeah, but I did it first try, which isn't normal, so I'm a bit confused on that.
Okay. Yeah, something's not right. Like these two, I don't think go together.
Which two are those? That's, yeah.
I think something is not right with those. And I don't think those are right either.
Are the ones
So,
you closed, do you think those ones are good?
I don't think so. Let me look.
Oh.
Oh, this one. Let me think about this one. I think this one is right. I don't think those are right. I don't think these are right. Like, I think you have the right idea, the way you're shaping them up, but let me just show you what I would look for. Okay.
All right.
So let me take something like, let me take something like this one. Okay. So if I were drawing tangent lines to this, right, they would all be positive tangent lines, right? Does that make sense here?
Yeah.
And then we'd have a little place where the tangent line would be 0 at 3. But then we also had but then it continues on and they're positive tangent lines, right?
Yeah.
So we need a graph that's positive, then touches 0 at 3, and then goes positive again.
All right.
So this one right here. So we need a graph that is positive, then touches 0 at 3. Do you see how this one does that?
Yeah.
Do you see how these two match up? See how this one's positive, it touches 0, and then it goes back to positive. That matches this graph.
Yeah.
So
All
those
right.
go together. So you really kind of want to hone in on the changes at the X values.
Okay.
Okay. So take a look at like this one. So look at this one. See how these are, if you drew tangent lines to this one right here, they would be negative tangent lines. Then they'd be positive tangent lines. Then they'd be negative tangent lines. Does that make sense?
Yeah.
So we need a graph that goes from negative to positive at 0 and positive to negative at 4.
Oh, all right.
And
Which would
that's
be
this one.
Yeah.
Now those go together. And then you keep on going from there.
All right. That makes more sense. Now I know what to look for.
Perfect.
All right. Thank
Right.
you very much.
Thanks, David.